Propulsion Lab at DevOps Belgium 2024. My next guest is my dear friend, a co-podcaster, a co-speaker, just like a friend. Just a co-friend, Pasha Finkelshteyn. Pasha, welcome.
Thank you for having me, Baruch. Happy to be here.
And we can see by your very official and polo shirt that you have a new-ish job.
New-ish job. I work there from May, I think.
Newish, still newish. Yeah,
kind of, sort of.
So you folks obviously all know Belsoft by Liberica, one of the most important JVM builds out there.
Yeah, but we should probably mention other products too. We have Liberica. It's a flagship JDK we propose to use to everyone. It's free, open source, and so on. As everything we do, all the products we do are free. But we also have our own Linux called Alpaquito Linux, which is a fork of Alpine. It's very nice. It's small, and it's with performance optimization specifically for Java.
So generally, Alpine known for cloud-native usage.
Yeah.
Right? The idea is that this is a very small distribution, and when we are talking about building images, base image of your operation system, size matters, and this is where we want the image to be as small as possible.
Yes.
This is how Alpine got its fame,
yes.
And this is everybody use that.
Yes.
So Alpaquito is the next step.
Alpaquito is just, it's a fork. It's optimized. It's slightly bigger, like a couple of 100 kilobytes bigger, but it's still under 4 megabytes. We follow it. We watch it very closely. And yes, it's optimized for Java, which is important for us. We built our Java for Alpaquito. We built Alpaquito for Java. We have our own base images on free and open source on GitHub or Docker Hub, sorry, which is very important. And what is even more important, for cloud native, security is a very important part of the pipeline. So we are trying to fix security vulnerabilities faster than Alpine. And we not only update our base image, which is Alpaquito base image, we also update all the downstream images. So all the Java distributions, Alpine is upstream. Downstream. So we rebuild our Java images. Each time you pull your JDK 21, 23, whatever you use, you have the most secure image we can provide, contrary to images based on Alpaquito, which are not usually rebuilt with newest versions.
Obviously. So just like a very simple advice, if you need a base image for Java, Alpaquito with Liberica is the way to go.
Yes, absolutely.
And it's one base image. You don't need to put Java separately on top of Alpine.
Yes.
You just take something that is already baked. You have the layers of the operating system and Java just packed as one base image. You start from there.
If you want to speak with me about cloud native stuff, I'll be there at KubeCon in North America in Salt Lake City in November, and our main topic there is obviously Alpaquito, not Java.
Yeah, of course. And then you actually come to visit my hometown, Nashville, for our Nashville Not Just Java user group.
I'll be there.
And end of November. So you folks, if you are in the area and you for some reason are not members of our Nashville Not Just Java user group, you definitely should be members by the time Pasha is there, because Pasha is going to speak there about crack.
Yes.
Hopefully not drugs.
Hopefully not drugs, but it can be addictive.
Okay.
You cannot smoke it, but you can use it in your application.
I don't think you smoke crack.
What do you do with crack? I'm sorry, I'm not big on drugs.
I'm not sure, but either shot it or sniff it.
Okay, you do neither of this in your application?
Don't, or outside of your application?
Should they put their thoughts in comments?
Absolutely. It's live on Twitter and YouTube, so tell us what you do with crack. But you know what? First, tell us what crack is.
Yeah, so crack stands for Coordinated Restore at Checkpoint. It stems from the project called CRU, Coordinated Restore in User Space. It's a Linux thing that says, let's perform this magic. You have this process running in your operating system, and it has memory. Let's just freeze its memory and dump it to the hard drive. And the next time you need to launch this application, you don't need the warm-up, you don't need anything. You just read the memory snapshot from the hard drive, you restore it back to the memory, and you are running.
It's like saving a video game.
Yes, but it's still video games still load a lot of time for a long time, right? It can take minutes for them to load. Java applications, which are checkpointed with crack, can launch from 10 to 200 milliseconds.
So I wonder if then the flow will be like, hey, I load my application, it takes a long time because Java, and then I preheat it.
Yes.
Right, I preheat the JIT. The JIT is getting warm, it starts optimizing whatever it optimizes, and then when it's the peak of its performance, we save it
Yes.
on disk,
Yes.
and then and then it's actually ready to go to production.
Yes, that's true. It's the perfect scenario. They're not that good scenarios, but they're still very good. For example, let's take your usual Spring application. Your usual Spring application, when you start it up, it starts hibernate. It scans your class path for entity beans and whatever, named queries and so on. It builds dependency tree, which takes some time. It initializes some beans, and it also takes some time. It initializes schedulers in your application. It also takes some time. And it starts a connection pool to your database. Also takes some time. They all take some time. Even if you didn't run your stress tests on your application, you can cut all this time for startup of the things. And this is usually what people are struggling with. Optimization is not that important. It will be optimized in a couple minutes after you start it, but warm-up time is crucial, especially when we are speaking about cloud-native things, because you cannot scale to zero if you know that scaling up will take minutes or potentially hours of your time.
Absolutely.
So this is the problem Crack is actually aimed to solve.
I see. Now, obviously there is a lot of spotlight is put on Java startup time
Yep.
in the cloud native era.
Yeah.
Because this is basically what prevents, one of the reasons that prevent Java adoption on the cloud.
Yeah.
The startup time. And obviously the Oracle, as the steward of Java,
Yep.
put a lot of resources into fighting that, and they do it through GraalVM.
GraalVM native image. Yeah.
So my question would be, what is the relationship? What are the pros and cons of using native images comparing to Cracked?
Oh, it's a beautiful question. I actually just answered it on my talk on Devox here like 10 minutes ago, 20 minutes ago, I don't know. The basic thing is, taking correct snapshot takes no time. It takes like 3 seconds in your build pipeline. But it has its downsides. I'll talk about them later if you have time. Native image takes a huge time to build. And for bigger applications, it's possible that it won't be enough, you won't have enough memory to build it. I have an example of application where 16 gigabytes of RAM is not enough to build it. Imagine that you have pipeline on your CI to build this application that we all have. Several developers commit their changes at the same time. You will need a mammoth amount of memory to build it. So it's, for developers, 64 gigabytes of memory and also many CPUs because it's slow.
And for us, Build Promotion Lab, speaking about developer productivity,
Yep.
GraalVM is not great.
Yes.
Because of the very long compilation time.
Yes.
In the end of the day, lots of, I think the main scenario is we will only do it on CI.
Yes.
We will build,
And only for production builds.
we will build a local build which is not GraalVM
Yes.
based, and then CI will do the native image. Now there is a huge problem in that.
Yes.
And this is just a local build is not representative
Yes.
of what happens in CI.
Yes, absolutely. They're different.
The problem with that is you don't have a confidence in your local build. You think that it's kind of, sorta,
Should work. Yeah.
but you don't really know.
Yeah, you know.
And this actually puts a very significant mental load on your work.
Yeah, or not, but then it means that you do not care, but you should care about your product.
We assume that people
Yes.
do care. And then actually you made a local build. And the optimal scenario is you run a local build.
Yeah.
It is short, you waited for it while while it runs, you verified that everything good, you made a commit,
Yeah.
and you're off doing something else.
Yes.
You don't think about this build anymore because you are pretty confident that what you built representative enough of what is
What
going
you
to
run,
happen in terms of CI, so CI should pass.
Yes.
Now, if that's not the case, I had exactly that conversation with Josh Long a couple of days ago on his Spring podcast, and he said, I have a shorter version of the build that I run, and I know that it's not comprehensive.
Yep.
But then I cannot concentrate while the CI build
Yeah, it
runs
just bugs him. Yeah.
because I'm waiting for it to fail.
Yes, absolutely.
And this is really devastating for developer productivity. And this is exactly the problem of deferring stuff to your CI and saying, well, we'll skip it in a local build.
So I have to be honest about crack here. The thing is, it's a Linux-only technology. You cannot build a checkpoint on macOS or Windows. It means that if you are a developer, you will have to build a jar file somehow and then put it into a container with Docker container with Linux inside it and create a crack checkpoint there. It's still much faster than, and you can totally automate it on your machine. It can be a simple bash script. That's what I did on my machine. It's still not as clean as we would in a perfect world would like.
Well, I'm not sure, because in the end of the day, you build a Docker image as a part of your local build anyway, because it is a part of your build.
Yes. But, you know, when it's pure Java, we can cut a corner. We can say that if it runs on my machine, I can call Java minus jar my jar file.
Yeah.
And it will do the same in Docker.
All right.
When something system-specific is involved, it's suddenly not that obvious.
I agree, but I don't think it adds a lot to add this step to your build of building your container, especially if your base image is already prefetched, you have it cached. And then it's, I don't believe it's such a, it's definitely simple and faster than trying to build native image. That's for sure, that's for granted.
Also, native image can do things crack cannot do, sadly. For example, Spring fully supports crack, so if you use only Spring provided things, your crack will work. Spring team guarantees it. But imagine that you have your own HTTP client inside your application, and Spring doesn't manage, you manage it. For whatever reason, you create gRPC connection.
Okay.
When you create a checkpoint, the TCP connection is broken.
Of course.
You have to recreate it somehow after restore. Spring cannot do it for you. So it's a little bit involved. You will have to write some additional code on top of it. You'll have to implement an interface called resource and implement a function called after restore. And in this after restore, you will have to recreate your connection, and you will have to write tests for it.
And obviously, if you just use a library that is not aware,
that you do not manage,
that is not aware of this functionality, it won't be there.
Yes.
And it will be a very nasty surprise.
Yes, you will have to either patch it for whatever reason. It's actually the first thing I hit when I experimented with it. I attached log4j to a Spring application, which is questionable, but for the sake of experiment, perfectly valid.
Yeah, no, it's absolutely valid.
Yeah, it's absolutely valid. And of course, I couldn't make my checkpoint because log4j logs to file, and file is an open handle. Spring is not aware of. It cannot close and reopen this handle. So I have to somehow hook into log4j and say, please, before checkpoint, close the file handle, and after restore it. It's also, there are some risks. What if file is not there anymore?
Of course, because you load it on a different machine.
Yeah, in a different machine.
This file. Absolutely. Yep.
So you have to think about, it's involved. But when we are speaking about cloud native things, I would say that you win a lot, but not too much involvement. Just, well, first of all, if you use Docker, we do not lock anything to files, right?
Yeah, of course. Yep.
It just doesn't make any sense. We lock to std out, problem solved.
Yes.
We also probably log somewhere to Kafka. It's very easy to work around with implementing one interface with two functions, and probably we need an actual implementation only for one of them, because TCP connection will be closed automatically.
All right. That all was very interesting. I learned about crack, and not the bad kind, but the good kind. Pasha, thank you very much for coming.
Thank you.
We are looking forward to see a demo of crack and hear an extended version of this chat at Nashville, not just Java user group.
We will probably also have it at DevOps Vision, will we?
Yes, we will
Even
have,
longer version.
yes, even longer. It will be like 90 minutes.
Yeah, well.
And it's all recorded. It's all will be online. So don't miss. If you want to learn more about crack, just follow Pasha. He's going to share all those resources. Amazing.
Thank you so much.
For you folks, stay tuned for more episodes of the Build Version Lab here at DevOps Belgium 2024. There are more coming. Thank you and bye-bye.